And our capstone project has been focused around reviewing Microsoft's SQL Server integration services for John Deere. Our presentation has been broken down into 6 parts, starting with the introduction all the way up into our postmortem, where we'll then open for questioning afterwards. Starting with the introduction, our project team includes myself, Derek Evanson.
Jack Morgan. I'm Ryan Nelson.
And we've also been in constant communication with our sponsor, John Deere. A little bit about John Deere is that they manufacture heavy equipment for multiple industries. So agriculture, construction, forestry, lawn care. Here based in Fargo, they manufacture their integrated electronics. That would be their embedded controls, their displays, their user interfaces, and their specialty sensors. Which comes down to the problem is that John Deere collects a lot of data. This is from manufacturing and customer orders. And they move this data back and forth between different databases and different facilities. In order to do this, they use ETL software, extract, transform, and load, to then extract the data from some sort of source, transform and modify it in some sort of way, and then load it to another destination. Currently, their ETL software has gone through some changes, and they have asked our project team to review Microsoft's SQL Server integration tools as a potential replacement for the next 4 to 5 years. So at the end of the project, we're going to hand them our deliverables and our final report, and with some additional research that they're going to do, they're going to determine whether or not the cost, features, and ease of use and the performance is worth the change. Starting with our solution is that we're going to set up our own ETL lab. So we ordered several virtual machines to use on campus at NDSU, and we installed Windows Server 2016. We are then going to set up mock data that kind of represents what they're using and test out what SSIS has to offer, SQL Server Integration Services. Now the process, we took an agile approach. So that means we had sprint reports, we had backlog that we were maintaining, as well as burn down charts. We divided our semester-long project into 4 sprints, each being 3 weeks, and that included 2 project team meetings that we had, one in the beginning and one at the end. Additionally, we also had a sponsor meeting every Tuesday. For our first sprint, we gathered our requirements. We pretty much figured out what were John Deere's needs, and we kind of reinforced what they wanted. We then constructed user stories, and then we researched what sort of SSIS components we needed to prepare for our design. In Sprint 2, we implemented our ETL lab. We installed our data sources and the components that were required for it. We populated with sample data, and then we pretty much tested the functionality to make sure everything was connected. Sprint 3, we then updated our goals, we reviewed our current process, and then we tackled all of our high priority user stories, and we started the final report. Sprint 4, we finished the remaining user stories, which were mostly focused on miscellaneous SSIS features, and then we completed and polished the final report. Now, some explanation of what ETL is it is extract, transform, and load, which is you're extracting data from a source, you're transforming it, you're modifying it, either adding to it or combining it with something, and then you're loading it to another destination, or maybe even the same destination. So an example here that we have on the bottom is we have a couple columns from a SQL Server database on the, I guess your guys' right, and then we are going to combine it with the columns with Oracle database on your guys' left. So ETL, kind of what it does is we create a package that has various tasks, and within those tasks we have stages in order to complete things. What we do is once we have this package, we then deploy it to a job, and then with that job we can then schedule it at a certain time. So we can have, let's say, 10,000 rows moved from Oracle to SQL at Monday 5 p.m. and we can also schedule another thing on Tuesday. We can also set up monitoring so we know what happens with the jobs, whether or not they've completed successfully or if they failed. We can set up notifications to email us like how long it's taking, whether or not certain stages within the actual job failed. We can also set up dependencies. So a job 1 has to be completed. If it does not complete successfully, we then also skip not only job 1, we can skip job 2, which was dependent. So what we have is for our ETL design is what we have all of our server 1 has all of our tools. And then our second virtual machine has all of our data sources. And then we allow access back and forth between them. Now ETL, and matter of fact, SQL Server Integration Services isn't just one sort of software. It has many components that you have to use interchangeably with each other. So on our server 1, we have Visual Studio, we have SQL Server Data Tools, we have SQL Server Management Studio, and SQL Server Agent. And then on the other virtual machine, we have our data sources, our Oracle database, our SQL Server database, our FTP server, and our file share. And our databases that we're using, we are filling with mock data, and we wanted to get a nice large variance of different data types with large amount of rows. So we used Microsoft's AdventureWorks for SQL, which has 1,000 records, and then we used Udacity, which had 4 million records. I'm going to hand off pretty much what we did in Sprint 3 and 4 off.
Thanks, Derek. So for Sprint 3, the two main things we focused on were tackling our Oracle client issue that we've been having and completing all of our main user stories for ETL jobs. So we'll quickly walk you through how this Oracle client issue came down. So the problem is that Visual Studio and SQL Server, they need an Oracle driver in order to access the Oracle database. And these are the particular drivers that we have access to. Now, in order to use those drivers, we have to download a particular software called Oracle Data Access Components. But this software actually has multiple bit versions of this that are available online, and they're each a little bit different. To complicate things, the particular runtime environments in which we're going to actually be running these packages are different. So for Visual Studio, if we're going to run packages there, we actually need the 32-bit version. But for SQL Server, we need the 64-bit version. So our first attempt at solving this issue was to install both of these different drivers onto our tools virtual machine. We actually ended up having a lot of problems with this. It took multiple weeks of trying to diagnose what was going wrong, and Oracle was just very difficult to understand. So we actually approached it from a different way. We had our original setup of 2 machines. We actually added a third virtual machine to this whole setup, and on here we replicated what we had put for our tools onto it. We also added the 32-bit Oracle driver, and just that one only. In this case, we actually got everything to work very well, and we were able to complete all of our user stories with this. In addition to focusing on that for Sprint 3, we also focused on completing our main high priority user stories, which focused on ETL jobs. The particular high priority ones were SQL Server database to SQL Server database, file share to SQL Server, FTP to SQL Server, and running an external script in SSIS. Some of the additional things we looked at in Sprint 3 were dealing with different execution styles, such as running the job ad hoc or in a batch, dealing with error handling in both the different job stages or for the whole job itself, and also dealing with logging and monitoring. In Sprint 4, we focused on the remaining user stories that we had committed ourselves to, as well as completing the final report. So the remaining user stories, some of the high priority ones, were dealing with Oracle, so SQL to Oracle or the reverse of Oracle to SQL. We also dealt with creating an external script that actually could manipulate data inside what was going on. And we set up different notifications so that if there was a particular stage in the job that wasn't working right, you could be notified by email. Or if everything completed fine, you could receive an email for that as well. Some of the additional user stories that we focused on were dealing with data type conversions between Oracle and SQL, dealing with dependencies between different jobs so that jobs have to run in a certain order, and if 1 or 2 of the jobs is skipped, the third one will run. Dealing with reporting, where you can understand exactly what happened in a job, record all the error messages and be able to review that easily, and also deal with administration features of being able to set up different users who can all jump in and start executing jobs. Finally, we wrapped all this up in a final report. So this kind of breaks down a little bit of the outline of what's going on, but really it's 2 sections. The first section has to deal with discussing the project as a whole and really the process we went through and the different decisions we made to make everything happen. And the second part really focuses on explaining the particular features of SSIS that we looked into in hopes that it will help John Deere make their decisions. And with that, Jack's going to lead us through a quick demo.
Thanks, Ryan. So I'm going to walk through a quick demonstration of a simple ETL job using SQL Server Integration Services and SQL Server Management Studio. And I'm doing this so that we can kind of see the life cycle of an ETL job from building it and then deploying it and executing it. So here's our scenario. We're going to extract data from this AdventureWorks database over here on the left. We're going to do some data transformation in SSIS, and then we're going to load the data into 2 different tables in this other database based on the data transformations that we did. And I'll talk about those tables in a little bit here. So here's a look into the source data. These aren't all the columns from the source table, but these are the ones that I'm kind of concerned with. And in particular, I want to look at the freight column and the subtotal column. Freight is basically how much we spent shipping the order to the customer, and the subtotal is the amount the customer owes us before taxes and freight. And so what we're going to do is build a new column on the right there that kind of tells us what the relationship between freight and the subtotal of the order is. So first, we got to open up Visual Studio. This is kind of where we do all the design work for an SSIS job. So we'll go File, New, and then Project. And then we need to specify that we're doing an integration services project. And I named this one Final Presentation. So things to note here is we've got a new GUI because we're in an SSIS package. We've got kind of our design window right here with different tabs for control flow, data flow, parameters. And then on the left, we've also got our SSIS toolbox. And that's where all of the components that we're going to use to build this job live. So first, we need a data flow task. These are kind of the bones of an SSIS job. This is where we do all of the actual extracting, transforming, and loading of data. So we're definitely going to need one of those. So we'll double click on that, and it'll bring us into this tab in the design window. And then over on the left, you can see our SSIS toolbox also changed. Our tools now are more for like directly working with the data. So first, we need to specify the source table. So we'll use that source assistant right up here. If we double click that, it'll bring up this window where we need to specify the source type, which in this case is SQL Server. And then we also need to specify a connection manager. And connection managers are kind of how SSIS projects and packages talk to data sources and data destinations. So those are very important. So I'm going to show us how to set up one of those really quick. So if we double click that new, we get this new window, and we need to specify the server name and the name of the database that we're going to be pulling from. So I filled those in. We're going to click OK. And now we've got this source task in our design window. It's still got that red X there because we haven't specified the exact table in the database that we're going to be pulling from. So if we edit that guy, we've got a tab right here for Connection Manager. And if we simply, if we simply fill it in right here under this dropdown and click OK, we've specified our table. So next, we're going to use a derived column task, and that's how we're going to build that column that we saw on the far right. So we'll double click on that, and we need to supply the derived column with data, and the way that we do that in SSIS is right here with these arrows. The blue arrow is for the standard output of a task, and then the red arrow is for the error output. So we're just going to grab that blue arrow and point it at derived column, and now that task has some data. And if we edit this derived column, we get this window with the variables and parameters and columns over here on the left. And then we've got on the right here functions, typecasts, and operators that we can use to kind of specify what data is going to go into this new column that we're building. So I've built one called freight percentage, and I've specified that we're going to add it to the data rather than replacing an old column. And then I've just made the expression basically freight divided by subtotal, and then I just had to cast it to a certain SSIS data type. So if we click OK, that guy's all set up. And now next we need to kind of tell the package which way to pipe output into the different destination tables based on that derived column that we just built. And for that, we're going to use a conditional split task. Once again, we need to pipe the output of the derived column into the conditional split so it has some data to work with. If we edit this guy, we get the same window as we did for the derived column. And I needed to build 2 outputs here, one called high freight orders and one called low freight orders. And the conditions for these, it's just based on that new column that we built. If the value is greater than or equal to 0.03, we're going to pipe it to one output. If it's less than, we'll pipe it to the other output. And I picked 0.03 because it was just kind of a nice median value that I found when I was looking through the data. So that's why I chose that. So if we click OK, then that one's all set up. And next we need to specify those 2 destination tables that we saw at the beginning. So we're just going to use a destination assistant up here, and it brings up the same window that we got for source. We need to specify a new connection manager because it's in a different, or these two tables are in a different database than the source table. I'm not going to show you how we set those up because it's just the same as the source. So we've got two destinations here. We need to pipe the output of the conditional split into the two of those. So we'll grab an arrow from that blue arrow from the conditional split, point it at this task, and with a conditional split, it'll ask you which output you want to move into this next task. So for this one, we'll do high freight orders, and then I did the low freight orders into the other destination. We still got those red X's down there, and the reason for that is we haven't mapped the input to this task to the actual column in the destination table yet, so we still need to do that. So we'll edit one of them. We'll just do high freight orders. And when we hit edit, we've got this window with the mappings tab. And it gives us this nice GUI for mapping from the input columns to the task to the actual destination columns in the destination table. So we'll click OK. And I did the same for low freight, but we won't look at that. So our package is now ready to go. We're going to deploy it now. And the way that we do that is we go over here and we'll right click and hit deploy package. So I'll hit next, and then in this wizard, we need to specify where our integration services catalog lives. So first we need to specify the server name, and once we've got that connected, we can just hit this browse button here, and it'll bring up our integration services catalog, but we have to specify a specific file inside of there to hold this job. So we'll hit new project, and we need to call it, I just called it demo. I'll click OK, OK, and then it gives us this review screen. I'll hit deploy. Looks like everything deployed correctly, so we're going to get out of Visual Studio and we'll move into SQL Server Management Studio now, which is where we'll be able to access that integration services catalog and schedule job and also execute it. So under SQL Server Agent right here, we can see that there's a files or a jobs file. We'll right click on that and hit new job. It'll bring up this window for us. So the job, we'll give it a name right here, final presentation. We don't need a description. And then we'll go to this steps tab right here. You can have steps in these jobs that aren't integration services projects, but for this one, we're just going to include that. So we need to create a new step for our project. So if we click new, we just have to give the step a name. We need to specify that it's an integration services package, and then we actually need to point it to the particular package that we want it to execute. So it'll bring us our integration services catalog. Once again, we specify the correct package, click OK. And now we can see that we've got a step in our job. Next, we're going to create a new schedule for our job. So we'll click new down there, and this brings up this window. For this particular job, I just wanted to show off that you have a lot of flexibility with when you can schedule these. I did this one in particular on Mondays at 8 p.m. And then the nice thing is that it gives you a nice little readout of what your schedule actually looks like down here in case you made a mistake. But we'll click OK. So we see we have a new schedule, and that's all that we're going to do for this particular job. You could also do alerts and notifications and targets over here, but we're not going to worry about that for the time being. So if we click OK, we can see that the final presentation job got added to the job folder under SQL Server Agent. But we actually do want to execute it ad hoc right now. So first I'm going to show us the destination tables. So I'm connecting to a different database here, and I'm just doing a simple select all into both of those tables. And we can see that they're both empty. Then we'll jump back into our integration services catalog, and we see our project right here, package right here. If we right click and hit execute, we'll get this overview window, and we can see that everything succeeded. And if we go back to our destination tables and we run that same select all, we can see that we wrote a little over 31,000 rows to each of those tables based on the freight percentage column that we built. So now I'm going to pass off to Ryan for the postmortem on our project.
Great, thanks, Jack. So let's do a quick postmortem on how this project went. The 4 things we'd like to look at are the successes, the setbacks we had, lessons learned, and recommendations for future work. So let's start with the successes. We started off this project not knowing anything about SSIS. It's not like we were doing a Java project or a JavaScript project, so we had a lot to learn. And from just the few short months we worked on the project, we were able to quickly get in there and master the particular aspects of SSIS that John Deere wanted us to look at. We also did pretty well with teamwork. We never worked together on a team, and just having to manage different schedules and all of these array of tasks we had to do, I thought we did a great job dividing it up and conquering it all pretty well. Finally, the third thing that we were really proud of is we created quite robust documentation and just went over and above what was actually required. As far as particular setbacks go, The first one we could talk about is choosing the particular platform for hosting our ETL lab. We'd originally anticipated using Microsoft Azure and started working using that software, but quickly realized that it would have been much better to host it at NDSU, so that actually required us to rebuild the whole system there. Another setback was dealing with version compatibility of software. When we set up the system at NDSU, we originally used Visual Studio 2017, but it actually turns out that the particular version of the Oracle software we needed to use wasn't compatible with this version that we were using for Visual Studio, so we had to go back and rebuild the system again. The third setback we had was dealing just with system configuration issues. We're not system administrators, and we don't focus on database administration here in this program. So we were struggling with having to set up the firewall correctly and deal with user accounts so that everyone can have access to everything and everything works correctly. And then we also had a setback with the Oracle client issue, but we talked about that already. So as you can see, this definitely impacted the velocity of our project. This is just a quick burn down chart of what we had originally anticipated the project would take as far as effort and when we'd get everything done. And you can see that over time, we just added more and more effort to the project to tackle some of these setbacks we had without John Deere adding any particular new user stories. So that leads us to lessons learned. Some of the things that could have really helped us is if we had installed the system more incrementally. And the idea is, as we're working with virtual machines, if we had been taking snapshots as we go and succeeded with one particular thing, that would have helped us. If we're struggling with something new, we can always roll back instead of having to rebuild the whole system again. It's also been really important to keep the sponsor in the loop. For the first half of the project, we've been meeting with John Deere pretty much on a weekly basis. And then in the second half, we were able to ease up a little bit and do maybe every other week, every 3 weeks. And this was really great for us. When we started the project, it gave us a way to very quickly dive in to understand what the project was about and what we needed to do. And later on, as we dealt with different issues, it gave us a sounding board and just helped keep everyone on the same page. Finally, the third lesson learned would be to seek out experts. So when we were first setting up these systems, especially with Oracle, if we were able to find someone who'd been setting up Oracle systems frequently and regularly, we probably could have avoided a lot of the problems we had early on and could have just saved us time in the long run. That leads us to the recommendations for the future. So SSIS can do a lot of things. As you saw in the demo, there's so much more it can do. Even that, though, it's a bare bones tool because it's free. So one of the things that other groups could look into is using third-party extensions. There's a lot of neat things that other people have created that complement SSIS, and it's worth exploring those. Another thing would be dealing with performance testing. We mostly focus on understanding the features and what was out there for what SSIS could do, but we didn't focus on how performant the system's actually going to be. So that's going to be very impactful for John Deere, and it's something to look into. The third thing would be dealing with scalability. SSIS works really well if you have maybe 10 to 15 jobs, but as soon as you have to deal with 50 or 100 different jobs in a production environment, the way the system actually organizes everything and keeps track of the different versions may not be adequate for John Deere's needs, so it's something to look into. And the fourth recommendation would be to consider the maintainability of multiple software components. SSIS isn't just a standalone software package that gets updated just by itself. It has 4 or 5 different components, and if they're all updating on a different schedule, that's a lot to keep track of, so it's really important to have a good plan moving forward of how you're going to approach that and keep everything on the same page. And with that, thank you. Do you have any questions?
I guess, was there any remaining work, or did it kind of turn out that everything that was agreed upon at the beginning was finished and there's not a lot beyond that?
Want to tackle that one?
I mean, there were stretch goals that we pretty much from the beginning decided weren't going to get done. The big thing was working with Docker. So we'd be basically resetting our entire ETL lab using Docker rather than, well, we were going to do Azure, but hosting it on NDSU. But we pretty early on discussed that that was just not going to happen probably. So we weren't committed to those. But everything that we were committed to, we finished.
A couple of little ones. You mentioned the documentation and things, which I think is exactly what John Deere wanted. But how big is that?
The document right now I think is 87 pages, so it's quite robust.
It's a lot.
Okay.
We're not every single user story that we did, because some of the user stories were dealing with final project and that, but a lot of the other things, I would say, 75% of the user stories are definitely thoroughly documented in that report.
Yep.
And then for each demonstration that we planned on having with John Deere on Tuesdays, we also had an alternative backup. So we also have pre-recorded videos and screen captures of what we would have demoed. That's
Sure.
also something we'd potentially include.
Right. Very true.
And the other's just kind of a little one, but when you schedule all these jobs, you had the one where you had a failure in the middle. Is rollback just included in what you do, or do you have to worry about that if you have a failure partway through?
Sure. It's something that I don't think is in part of SSIS itself. That would be more to deal with the particular database management system that you're using, and whether it's transactional based or how you actually approach it there. So if the job fails to run, it's going to complete all the steps up until that failure, and it doesn't roll anything back. So you might have a cleanup step in your job that looks through and says maybe if something fails, it skips to a later step which rolls things back. So you could definitely manually include some of that, but it's not set up inside SSIS itself.
I would definitely set up a situation that if task B was dependent on task A, it would then, if task A failed, it would switch over to task F, which would handle all the cleanup duty and just revert everything.
Yeah, right.
And then just to be safe, I'd also probably add in a notification step.
Sure.
Yeah, sure.
Yeah.
Any other questions? Thank you.